Alright, welcome to today's how-to video. Here I'm going to be showing you how to operate and start up the nuclear reactor in this game, Pressurized something like that. Anyway, so first things first, you're going to want to hit the activate switches on all of these and turn on all the control panels. Gotta go through them one by one. Alright, now that everything's turned on, we can begin the first step of starting the reactor, which is to turn on the pressurizer module here. You do that by flipping on the thermostat so you can watch its temperature, then turning on the heaters. Now you can see here in this gauge that it will slowly start to build up pressure. You can see that value going up. Now the reason why the pressurizer is important is because in most standard reactors they use water as a cooling system, but the reactor reaches temperatures well above the boiling point of water. So by pressurizing the entire reactor system, it allows the boiling point of water to become much higher so you can operate at the temperatures of the reactor without it all just evaporating away. So you can see in the green range, and typically you're going to just want to keep it around 160 bars of pressure, which just means an atmosphere. When that happens, you can either turn off the heaters entirely to let it slowly go back down, or you can just set it to a low setting. If it ever actually does get too pressurized, then you can open the valves here by switching it to the right. Alright. The next step is to initiate the coolant flows. So when you start this game, you initially only have number 3 as a coolant loop. The rest you have to unlock. But for now, we could just set this to medium and turn it on. Now coolant will start flowing through the reactor, and you should get a message see at the bottom. Next, you want to turn on the coolant flow for the condenser. Put it on medium and start it, and start the vacuum pump as well. Now, the coolant system, the primary coolant system, just flows the water from the reactor core to the steam generator. The steam generator is what actually boils the water into steam to spin the turbines. Next, the steam goes through a loop to the condenser to be condensed back into water and returned back into the initial coolant system. The condenser here has its own tertiary coolant circuit where it just cools itself from getting too hot. Meanwhile, the steam generator is directly tied to the primary coolant system. However, it has the secondary coolant system between the steam generator and the condenser. So that's all the coolant flows. One thing to note is that the coolant flow from the primary system, the one connected to the reactor, directly correlates the temperature in the steam generator, because that's all just hot water coming fresh from the reactor. Pretty much what the controls here do is just keep your volume level in the clear. So as it wants to go down, you're just going to want to turn up the flow speed to try to keep that needle in the green. Now here, as you start up, you have a very low volume level in the condenser, which you can turn on the freight pump here, which says condenser pump, to help load it with some just extra water in the reserves. So that should start to go up momentarily. The pumps take a second to start up. Oh yeah, BC is going up now. So you definitely do not want to overflow it, and I honestly don't know how yet to empty it. So let's just try not to overflow it too much. Once it starts to barely hit the green, we could go ahead and turn off the freight pump. Go ahead and turn the freight pump off. Alright, now we can actually begin starting the reactor. Now we want to go here and turn the operation mode to nominal, so the computer systems now know that we're gonna start everything up, and it'll give you the basic operation parameters for this operation mode. Then you're gonna want to hit the insert in core button for the fuel core. That'll insert the fuel into the reactor core. Next, you're going to want to go here, and this is the height of the control rods. So 100 is closed, but when you lower it just a little bit, that means that it will actually start reacting, and that'll start generating heat. So for now we can just set it to 97, and usually you don't ever want to go much lower than that. 97 is a bit on the impatient side. But here you'll see the temperature is now starting to go up slowly. I'm going to increase this to 95 because I'm a bit daring today. Alright, now that this is all finally beginning to start, you can open your tablet here. You're going to want to request to start operations to the city so that the power grid is ready for you. Hold on, we got a little cutscene here. So what that was all about means the reactor just hit critical mass, which just means that it's reached a temperature enough to be able to sustain its own chain reaction. So now that's just going to build up heat. Now once the steam generator starts to reach a temperature of around 140 will be when it actually starts to generate steam. You can see here it's currently at 100. And honestly, because we don't want its temperature to be too high right now, because we want energy production to be a little lower, we're going to put the primary circuit coolant speed to slow for now. And you might be thinking, but wouldn't that mean your reactor will overheat? No, not if you keep the control rods from letting it build up too much heat in the first place. Right, so now we're just waiting for the whole system to heat up. I'm going to check on the pressurizer over here. So it actually started to lose a bit of pressure, so I'm going to turn the heaters back on. And once it reaches 160 bar again, I'm going to just turn this heating power to low so I don't really have to worry about it too much. Okay, so you see here I'm just switching it to low, and now won't very drastically increase anymore. It's actually slowly decreasing a little bit. It's fine, is what it is. That's what it is. So because we set the operating mode to nominal, we can see here that the operating range is 306 Celsius, so that's where we're going to want to keep it once we start to reach that temperature. Oh, so can't forget, I almost forgot that you need to turn on the resistor banks. I'm getting a warning here. Alright, saying that I have low volume in the steam generator, that's because I forgot to turn on the flow here. So I'm going to go ahead and switch to 3 version and put it on medium for now so I can get that coolant back in its tank. No worries quite yet though. As I was saying, so you're going to want to turn on the resistor here. What the resistor does is it stores the excess energy produced that the power grid is not taking. If you do not do that, then damage will happen somewhere. As you can see here, the absorption capacity of the current resistor bank is 5,000 kilowatts, and here effectively derived energy is all the energy that is being derived to the resistor banks. Currently it's none because they're not really producing anything yet. And to be honest, I don't know why that is. Anyway, so you can see here the communication systems with the city that we have confirmed operations at 11 hours. It's currently 10:22. Also, the reactor is already starting to get too hot, so I'm going to immediately set it to 100 to close it and let it start cooling down. 400 is about the temperature where you want to start getting concerned, so that's not too big a deal, but remember that our desired operating range was 306. So actually, once a vacuum is reached within the condenser, you can go ahead and turn off the vacuum pump to save a little bit of power. Also, I'm not sure why this hasn't been a problem yet, but I kind of forgot to press this switch here to start using the external power supply. You have to pay fees to the city every now and then, but that's okay. Also, I think it was just because we're using on emergency battery power. So good thing I remembered about that. Right, because we're just kind of waiting here, I'm going to... Okay, so you see this is starting to fill up the coolant tank a little too much. It's not in the middle of the green, so I'm going to turn this back down to slow. Anyway, now that we're waiting here, I'm just going to turn up the speed to... until we get to 11 hours where we can actually start to connect to the city's power grid. So we can see here from Gen 0 to they're actually producing a little bit of power now. Also, this just skyrocketed to 5,000, which is the capacity of the resistor. That is very bad because it means it'll very quickly fry the resistor. So here I'm cranking up the turbine bypass valve, which means the the steam will bypass the turbine entirely and route straight to the condenser. The only downside of this is that it can cause the temperature to raise in the condenser, but that can be solved by just cranking the coolant circuit flow speed for the condenser. And I can see that after I crank the bypass valve, it's already started to reduce that derived energy here. So we're actually producing a bit of energy here that you can see from generator 03. There's a little extra, so I'm going to just put this down to like 35 for now. So I'm turning the speed back up again. Alright, so the temperature is now in more desirable range, so I'm just going to set this to 99. We're going to want to check on that frequently. Alright, we finally hit 11 hours, which means now the city is starting to demand power, and first we need to synchronize our voltage to the city's voltage system, because that's how power grids work. And we can do that by using the synchroscope to tell if our frequency is either too slow or too fast. So currently it's spinning left, which means it's going too slow, which means we're going to want to increase the power a little bit. Since currently we're using the bypass valve, so all we have to do is turn that down. But if you're not quite generating enough power, then just kind of turn up the primary circuit coolant flow speed here, so that we'll get a little more heat to the steam generator, getting you a little more power. Alright, so one thing to note about operating a reactor is that everything you do will take time to catch up because every system works with each other. So we're still going a little too slow here, so I'm gonna lower this bypass valve some more. Alright, now it's much more in range. So now we can just take control of these buttons here to raise and lower the RPM. I'm still doing too slow, so I'm just going to keep hitting the RPM button. What we're trying to go for is to get it to stop right there at the top in the middle. Alright, there we go, we got it. Now we can hit the close button, and now we are synchronized to the city's power grid. As you can see in this panel, where the city demands 5,000 kilowatts of power, and there it is. They're delivering 4,800 kilowatts of power. So we're not quite meeting that demand, so we're going to turn the bypass down to 0. And all the excess that you produce will go into your resistor bank. Now, the more energy that's going to your resistor bank, the more wear it's going to take, but you definitely cannot go over the capacity, which is currently 5,000 kilowatts. So I'm just kind of checking out all the other systems here. The level of this steam generator here, the coolant levels are a little low, so I'm going to turn up the flow speed to 35. Alright, we're now meeting the demand, and we have just a little bit of energy going to the resistor bank, and that's perfectly fine. I try personally not to go over 1,000, but you can always leave a little bit of a buffer. It's no big deal. Alright, so our pressure's okay. The temperature is a little high. I'm going to want to set that to 100. So let it start to cool down again. Oh, we're suddenly not generating enough power. We can solve that by just turning up the flow speed a little bit. Turn that to 35. Deliver more heat to the steam generator. Alright, we're meeting power demands again. So that's it. Throughout the day, you can see on your tablet the service compliance. There's estimates for the amount of power they'll be needing. But the simple operation is keeping your reactor producing more energy as it demands or producing less energy as it demands. And that is my how-to video.